The ASX was an early axial flow jet engine built by Armstrong Siddeley that first ran in April 1943. Only single prototype was constructed, and it was never put into production. Turboprop version as the ASP was somewhat more successful, and as the Armstrong Siddeley Python saw use in the Westland Wyvern. History: in December 1941, Metrovic ran its Metrovic F2 engine for the first time. While successful, the engine was too heavy to be useful aircraft engine, and the Royal Aircraft Establishment (RAE) felt this was likely due to Metrovic's history as steam turbine company without much aircraft experience. The RAE approached Armstrong Siddeley to help with the design, both to improve the F2 as well as to get AS familiar with turbojet design so they might build their own designs, or others under license. However, Metrovic refused to have anything to do with them, and no amount of effort on the part of Armstrong Siddeley or the RAE would change their opinion. Now highly interested in jet propulsion, Armstrong Siddeley began looking for other designs they could work on, and eventually hired Fritz Albert Max Hepner. Hepner had designs similar to the early designs of Alan Arnold Griffith, in that the engine did not use separate compressor and turbine stages, but combined the two by attaching an individual turbine stage to each compressor stage, and rotating each stage in opposite directions. The main difference between Hepner's design and Griffith's was that the stages were not connected to central shaft, but instead to surrounding rotating shell. The RAE was not impressed with this ASH design, and repeatedly refused to provide funding for its development, suggesting instead much simpler design. Another major critic of the concept was AS' own chief engineer, Stuart Tresillian, who had grudgingly taken the post in 1939 at the request of the RAE. The AS board fired Tresillian in January 1942, submitting the latest design proposal and once again having it rejected. It was not until August 1942 that the company was finally convinced to begin work on simpler design. Like the F2, the plan was to use the RAE's compressor designs while AS would develop the turbines and the rest of the engine. This new experimental design became the ASX. An order for 6 examples was placed in October 1942, and the contract signed on November. The engine ran for the first time on the 22nd of April 1943, only 166 days after the contract was signed. The engine was soon producing 2,000 lbf. As soon as the Air Ministry was satisfied the company was able to make engines, they granted AS permission to make Hepner-derived version. However, the company gave up on this as well, and decided to instead use the ASX as the basis for turboprop, which became the ASP. Thus the first example of the ASX would ultimately be the last as well. Testing continued on the ASX through the rest of the war, and by the 20th of April 1945 it had run for a total of 22 hours. Although AS and Metrovic were not able to collaborate during the war, in the late 1940s the Ministry of Supply forced Metrovic to spin out their gas turbine division and handed it complete to AS in order to reduce the number of firms in the aviation business. Thus AS ultimately ended up with the F2, and more importantly, the F9 that would become the Armstrong Siddeley Sapphire. Design and development: the ASX was unique in layout. The inlet to the 14-stage compressor was placed near the middle of the engine, the air flowing forward as it was compressed. From there it fed into 11 flame cans arranged around the outside of the compressor, flowing back past the inlet, and finally through the turbine. This layout allowed the compressor and combustion areas to be folded together to make the engine shorter, although the overall reduction in the case of the ASX appears to be fairly limited as the engine was almost 14 feet 4.3 meters long. Additionally, this layout makes it more difficult to service the compressor, although, at least in modern designs, it is the hot section that generally requires most servicing. The ASX was flight tested fitted to the bomb bay of modified Avro Lancaster, ND 784, the first flight taking place on 28 September 1945. At full power the engine ran at 8,000 rpm and developed 2,600 lbf 12 kilonewtons, of thrust at sea level. For cruise the engine ran at 7,500 revolutions per minute and developed 2,050 lbf 9,1 kilonewton. It weighed 900 pounds, 865 kilograms. The ASP conversion used second turbine stage to drive the propeller through gearbox, producing 600 shp, as well as 100 lbf, 9 kilonewtons, of leftover jet thrust. Applications: Avro Lancaster, test only. Specifications: ASX, data from aircraft engines of the world 1946. General characteristics: type, axial flow turbojet length 167 in, 424 2 cm, diameter 42 in, 106 7 cm, dry weight 900 pounds, 860 kilograms, components: compressor 14, stage axial reverse, flow compressor combustors 11 stainless steel can combustion chambers arranged around the compressor turbine 2, stage axial fuel type, kerosene oil system, pressure feed to bearings, dry sump performance maximum thrust 600 lbf, 12 kilonewtons, at 8,000 rpm at sea level. Overall pressure ratio 5, 1 turbine inlet temperature 220 degrees Fahrenheit, 660 degrees Celsius, specific fuel consumption 103 lbfh, 105 kilograms, knh. Thrust to weight ratio 1:37. Military thrust, static 600 lbf, 12 kilonewtons, at 8,000 rpm at sea level. Cruising, static 2,050 lbf, 9 kilonewtons, at 7,500 revolutions per minute at sea level. Idling, static 130 lbf, 1 kilonewton, at 3,000 rpm at sea level. See also related development. Armstrong Siddeley Python related lists. List of aircraft engines. References, notes, bibliography. External links. Armstrong Siddeley ASX flight, September 1946.